Hello to you all. Good morning and welcome to another class. Today, our focus will be on trigonometric identities and equations. So this will be our focus for today's class. We have come a long way doing trigonometry. We have done for the graphs. We have done for sine and cosine rules, solving trigonometry using sine and cosine rule for bearing, looking for angles and the rest. But today we will focus primarily on the identities and the equations. So we are going to be looking at angles in 4 quadrants. This is our primary focus for the class. And in angles in 4 quadrants, we are going to look at how we can find the values of the trigonometric ratios in the 4 different quadrants. So our ability to calculate the trigonometric ratios of different angles will be tested, and also to analyze and find the value of the trigonometric ratios of negative and positive angles. So this is what we'll be focusing on: trigonometric identities and equations. Before we go, I would just like us to get this, to look at this here. We'll be using this to find the values of given trigonometric ratios. Because you're expected to know your trigonometric ratios, the angles for sine, cosine, and tan of the given angles below. Because sometimes we use the trigonometric ratios for our trigonometric identities and not normal sign of these angles. So I'm going to start with the first here, which is a right angle triangle. On that right angle triangle, we have our hypotenuse side here. We have opposite to 45 here. Then we have our adjacent at this point. So we're going to be solving for sine 45 degrees. So looking for sine 45 degrees, as we earlier established on our trigonometry, we have SOHCAHTOA, that is what we've been using, where we have our SO as sine theta, and our CA as cosine theta, then our TOA as tan theta. So this is our focus. We use that for solving our trigonometric ratios here to find the values of the sine of angles and cosine and tan of angles. So for sine 45 degrees, you already know sine is opposite over hypotenuse. So the opposite of that 45 degrees is 1, and the hypotenuse is root 2. So this is sine 45 degrees. The trigonometric ratios for sine 45 degrees is 1 divided by root 2. Then we have for cos 45 degrees, we have cos 45 as adjacent divided by hypotenuse. The adjacent to that is 1, and the hypotenuse is root 2. So we have that same as our sine of 45. Then we move on to tan 45 degrees. We have tan 45 as opposite divided by adjacent. So that means the opposite of that is 1, and the adjacent is 1. So tan 45 degrees is equal to what? 1. So we have it as 1. Take note, your sine 45 and your cos 45 have same value. Then we move to the second triangle, which is an equilateral triangle. Okay, so on this angle here, I have 60 degrees here, I have 60 degrees, but the 60 here divided into 30 and 30 degrees. So for an equilateral triangle, like you know, all sides are equal. Here is 2, here is 2, and here is 1. So you can choose any part of this in order to find your trigonometric ratio. So the first ratios we are looking for there is sine 30 degrees. So sine 30 is opposite divided by hypotenuse. So where's the opposite of sine 30? This is opposite to sine 30 here, which is 1. And our hypotenuse on that side is 2. So we have 1 by 2. So I have cos 30 degrees. Cos 30 degrees will give us what? Adjacent by hypotenuse. The adjacent to 30 degrees is root 3. So I have root 3 divided by 2. Then we have tan 30 degrees. So our tan 30 degrees is opposite by adjacent. So we have 1 over root 3. So these are the values for our sine 30, cos 30, and tan 30 degrees for giving trigonometric ratios. Then we have for sine 60 degrees. So 60 degrees is what? Opposite by hypotenuse. So the opposite of 60 here is root 3. So we have root 3 divided by, where's our hypotenuse, which is 2. We have same for cos 60 degrees. Cos 60 degrees is what? Adjacent by hypotenuse. So the adjacent to 60 is what? 1 divided by 2. So cos 60 degrees and sine 30 degrees are same. So take note of that. Sine 60 is equals to cos, sine 30 degrees is equals to cos 60 degrees. So we move further to tan 60 degrees. So we have tan 60 degrees, which is what? Opposite divided by adjacent. So the opposite is root 3 divided by 1. So that gives us root 3. So take note of this formula here. Sine 60 degrees is equals to cos 30 degrees, and cos 60 degrees is equals to sine 60 degrees. So what are the trigonometric ratios? These are the basic trigonometric ratios you should be familiar with in order for you to be able to solve for trigonometric identities. So now we'll move to our main focus for today's class. This is just a preview of what our trigonometric ratios for sine, cos, tan of 45, 30, and 60 degrees look like. So we'll move to our quadrant. So we explaining the principle of quadrant. We are going to have our x and y axis. This is my y axis, okay? And let me draw it out clearly. This is my y axis, and this is my x axis, okay? So we have our y and we have the x axis. These guys are divided into 4 different quadrants. So this is the first quadrant, and this is the second quadrant. This is the third, and this is the fourth. You can see I'm moving in an anti-clockwise direction. This is my anti-clockwise movement, okay? But if I'm moving in the clockwise movement, this becomes first quadrant, second, third, and fourth quadrant. So these guys are divided into angles. Where we have this point here to this point here as our 0 to 90 degrees. That is for the first quadrant. And that point we call it pi by 2. That is if I'm moving in what? In an anti-clockwise direction. So I have it there as pi over 2. Or you can have it as pi 3 pi over 2, which is positive or negative 3 pi over 2 for that angle. Then we move to the second quadrant. On this second quadrant, I have it as 91 to 180 degrees. So that is why we have plus or negative pi, because we know pi is our 180 degrees. Then for the third quadrant on this axis, moving this way, ranges from angle 181 to 270 degrees. So we have 3 pi by 2. 3 pi by 2 is 270 degrees. Please refer to our videos on trigonometry, the previous videos we have. You can learn how we got these angles from 3 pi over 2 pi and pi over 2 with 2 pi. Then for 360 degrees, here the fourth quadrant here ranges from where 271 to 360 degrees. So which we have as from 2 pi. So these are the 4 quadrants we talk about. So this is not just enough. In applying to your trigonometric identity, the essence of this quadrant, we want to take a look at this. In this first quadrant, I have what we call all is positive here. When we mean all is positive, I'm talking about my sine, my cos, and my tan of angles. On this first quadrant, they are all positive. So So when you have sine 45, cos 45, tan 45 on these angles, they give us a positive value. So for whatever value you have, and I say this first quadrant is from here 0 to 90 degrees, excluding your tan 90 degrees, which is call it when you press on your calculator, you have a math error on this part. So we have every other values ranging for this as what? A positive value. Then when we proceed to this part, like I said, this is all, everything here is positive. So proceeding to the second quadrant on this axis, I have my sine theta. So only the value of sine theta here is a positive. Every other value that is for your cosine and tan on the second quadrant are negative values. So take note of that. Every other values are negative except sine, which is positive on this angle. And I say that angle ranges from 91 to 180 degrees on the second quadrant. Then moving to the third quadrant, we have 181 to 170. On this angle, we have our, this is all positive here, take note of that. We have our sine. Then for this, I have on the third quadrant, I have my tan theta to be positive. So on the third quadrant, every other angle that is sine and cosine are negative. So only the tan of angles are positive on the third quadrant. So please take note of that, and that angle ranges from 181 to 270 degrees. Then for my fourth quadrant, on this guy, I have my cosine angles. Cos theta is positive on the fourth quadrant. Every other angle that is including your sine and your what tan are negative. So this is the quadrant we talk about. So you can see it here. Then here we have the first quadrant, then we have the second quadrant of this angle, then we have our third quadrant, then we have fourth quadrant. So moving in an anti-clockwise direction, then moving in a clockwise direction, we have it this way too. So we can use this quadrant to determine whether each of the trigonometric ratios is positive or negative, like I've explained earlier. So here all is positive for angles theta in the first quadrant, sin theta, cos theta, and tan theta are all positive. Then for this second quadrant here, angle theta in the second quadrant only sin theta is a positive guy. Then for the third quadrant, we have our tan guy, which is positive, and for the fourth quadrant, we have our cos theta, which is positive. So what is a cast diagram? A, S, T. So moving this way, this is C, A, S, T. This is cast. Okay? Or we can have it A, C, T, N. Act. So anyone you want to use to memorize this is okay. So we have the cast in an anti-clockwise direction and act ACTS in a clockwise direction. So take note of that. We will need this to know our quadrant and which angles are positive or which is negative. So proceed to use this to solve equations in trigonometric identity. So looking at this now, we are going to use this rule to find sine, cos, or tan of any positive or negative angle using the corresponding angles marked to the x-axis. So like we said earlier, we looked at this, all is positive, so nothing is being done there. So we move to the second quadrant, which we have our sine of angles as positive. So that means we are saying sine 180 minus theta is equals to sine theta. That means sine of angles is positive there. Then when we have sine 1 cos 180 minus theta, that means cos is negative. Take note of that. Then when we have tan 180 minus theta, it will also give us a negative tan. So because we say only sine is positive for our second quadrant, then for the third quadrant here, we have sine 180 plus theta. That means it's what? Negative sine theta. Then we have cos 180 plus theta, which is also what? A negative cos theta. Then we have tan 180 plus theta will give us us what? Tan theta, which is positive on that axis. Then when we move to the fourth quadrant, which is cos, on that angle we have sine 360 minus theta. Sine is what? The negative side. Then cos 360 minus theta give us what? A positive cos theta, because cos is the only positive angle in this quadrant. Then tan 360 minus theta will give us what? A negative tan theta. This is applied here using, if you look at this, is the same. Then we are using our radians. So we have sine pi, which is replacing 18. 180 sine pi minus theta gives us what? Sine theta. Then cos pi minus theta gives us negative sine theta. It's the same thing for this. So we are just replacing 180 with pi, and here we are replacing 360 with 2 pi. So this is what we are doing here. Okay, so just take note of that using your pi values or your angle values. So we are giving this example here. We have to find the exact value of sine negative 210. So if sine is negative on this axis, we have said that means the only negative guys here are what? Cos and what? Tan. So that means it's either a cos or a tan of an angle. So how do we resolve when this guy is negative? So simply we can draw our quadrants. It's optional if you want. It's not compulsory. You can solve it without drawing this. So we are looking at sine negative angles of 210 degrees. So we said cos 118 minus theta will give us a negative cos. Then we have sine 180 plus theta, which is what? A negative what? Sine theta. So what angles do we have on that? So sine is negative where? On your third quadrant and on your fourth quadrant. Are we okay? So that is where we have the values of that. So what I will have mine on this quadrant here. Sine negative is what? Sine 360 minus theta. Sine what? 360 minus theta. That means we have 360 minus 210 degrees. We give us what? 150 degrees. So that is the angle we have there. Or we have on this angle 180 minus 210, or 210 minus 180. We give us the second values because we are supposed to have two values for this. So we have 210 minus 180 degrees will give us what? 30 degrees. So gotten the angles at that point, which is what? 150 and what? 30 degrees. So we have it this way, our 150 degrees this way. So this is the sine, which is positive on this. Then we have, this is for 150 degrees. Okay, so I can have my line here. Is that okay? So we can stop here. That is for our angle 150. Then we have here for our negative 210 degrees. So on this, we can say sine 30 degrees or sine 150, any one of them. Going back to our trigonometric ratios, we know sine 130 is what? 1/2. So we've gotten the exact value of sine 210. Then we are looking for the exact value of tan 75 by 4. So we are looking for this value 75 by 4. So if you take a look at this, we have this. Okay, so we have A, okay, so we are looking for a positive value of tan. So tan there is a positive value, and like I said earlier, this is our pi by 2. negative 3 pi by 2. We have here as a pi. Then we have 3 pi over 2. Then we have here as what? 2 pi. So we are looking for what? 7 pi by 4. Then we have, since we are looking for tan 7 pi divided by 4. So our tan is only positive. The positive values we have is on this axis. Okay, we have positive tan here, and here we have positive tan on my third quadrant. So this is 3 pi over 2. Simply what I do to find that value, I'll have 3 pi over 2 minus 7 pi over 4. So 3 pi over 2 minus 7 pi give us 4 divided by 2, that's 6 pi minus 7 pi. So answer is minus pi by 4. I already know that pi is 180. That means I have minus 180 divided by 4, which will give me minus 45. So I'll have tan negative 45. So tan negative 45 will give us what? Negative 1 from our trigonometric ratio. So we have tan 45 as 1. So this is how to use our trigonometric identities. So for positive and negative values of sine, cosine, and tan. Earlier, the address something here was supposed to be this. Okay? This angle is supposed to step from here. So we have that as negative 210, and this angle ends here as 150 degrees. And then let's try to solve more examples. I'll give you more to solve on your own. We are expressing sine negative 100 degrees in terms of trigonometric ratios of acute angles. So we already know that for where sine is negative, we have these values for it. I'll refer you back to this on sine 180 plus theta is what? A negative sine theta. So we are looking for the negative sine theta of that. That means I have 180 minus 100 degrees. So we have 80 degrees. So you can draw the angles for that. Using this. Okay. So we have our sine, our tan, we have cosine, and we have positive. So we have the negative values for our sine theta from here, from the second quadrant to this point here. Okay. So we have this as our negative 100, sine negative 100 on this. So we have for cos 330. You know, cos is positive where? On the fourth quadrant. That is where it is 360 degrees. So for cos 330 degrees, we can have 360 minus 330, which is what? 30 degrees. So the value for cos there is what? 330 and what? 30 degrees. Because both of these guys are positive. So also you can draw so please try and solve for the others of tan 500. At this tan 500, please take note that your arrow has to move twice the quadrants. Okay, because you have tan 500. Simply what I will do there, I'll have 500 because tan is on 270 degrees minus 270. So take away another 270 degrees from it. I think the balance here will be what? 40. So the angle at that point should be 40 degrees. So please solve for this. The previous example I used here. So Please refer to that in order to solve for your course inverse of this sine 2 pi over 3 and tan 11 pi is for trigonometric ratio of acute angles. So there are more questions for you to watch, so please go through if you have. So taking a look at this further examples, we are actually for cos 37 degrees and sine 312 tan 190 cos 11 pi over 6 sine 7 pi over 6 and tan 11 pi by 4. So cos 237 will give us what? That value cos is positive on that angle. So what do we have on that angle? So we just have 237 degrees minus 180 degrees from cos 237 degrees. So that gives us what? 57 degrees. So on that, I will have it as cos minus 57 degrees. Give me for the acute angle of my cos 237. So I'm written as minus cos 57 degrees. So we've gotten that for cos 237. So please apply that to other questions. Please we'll go on to the next video for trigonometric identity. This is for trigonometric ratios of angles. For sine, to take it either positive or a negative. For sine